The Milky Way is the galaxy that contains our solar system. It is a spiral galaxy, with a central bulge surrounded by a disk of gas, dust, and stars. The Sun is located in one of the spiral arms, about 25,000 light-years from the center of the galaxy. The Milky Way is about 100,000 light-years in diameter and 1,000 light-years thick. It contains about 100 billion stars, as well as a large number of planets, moons, asteroids, and comets. The Milky Way is moving through space at about 600 kilometers per second. It is also rotating, with the Sun completing one orbit around the center of the galaxy every 250 million years. The Milky Way is not the only galaxy in the universe. There are billions of galaxies, of all shapes and sizes. The Milky Way is part of a group of galaxies called the Local Group, which also includes the Andromeda Galaxy and the Triangulum Galaxy. The Milky Way is a beautiful and mysterious place. We are still learning about its origins, its structure, and its evolution. But one thing is for sure, the Milky Way is our home. The name, Milky Way, comes from the Greek words, galaktikos kyklos, which means, milky circle. This is because the Milky Way appears as a hazy band of light in the night sky. This is because the galaxy is viewed from within, and the stars in the disk are too close together to be seen individually. The Milky Way is a very active galaxy. There are many star-forming regions in the disk, and there are also many supernovae that occur. Supernovae are the explosions of massive stars, and they can be very bright. The last supernova that was visible to the naked eye in the Milky Way was in 1604. The Milky Way is a fascinating place, and we are still learning about it. It is our home, and it is a part of our history. The Milky Way is composed of a variety of celestial objects and components. Here are some of the key components that make up the Milky Way galaxy. 1. Stars. Stars are the primary constituents of galaxies, including the Milky Way. Our galaxy contains hundreds of billions of stars, ranging from relatively small and dim stars to massive and luminous ones. 2. Planets. The Milky Way contains planets, including our own solar system's 8 planets. These planets orbit around stars, and some of them may potentially host conditions suitable for life. 3. Gas and dust. Interstellar gas and dust are found throughout the Milky Way. These materials play a crucial role in the formation of new stars and planetary systems. Dust particles can block and scatter light, leading to the appearance of dark patches in the Milky Way's band as seen from Earth. 4. Nebulae. Nebulae are vast clouds of gas and dust where new stars are born. They can emit light at various wavelengths, creating beautiful and colorful structures in the galaxy. One famous example is the Orion Nebula. 5. Star clusters. Star clusters are groups of stars that are gravitationally bound to each other. There are two main types: open clusters, which contain relatively young stars, and globular clusters, which are much older and densely packed. 6. Black holes. The Milky Way is thought to contain a supermassive black hole at its center, known as Sagittarius A. This black hole has a mass of millions of times that of our Sun and influences the motion of stars around it. 7. Pulsars. Pulsars are highly magnetized, rotating neutron stars that emit regular bursts of radiation. They are often remnants of massive stars that have gone supernova. 8. Galactic halo. The galactic halo is a region surrounding the main disk of the Milky Way. It contains a sparse population of stars and globular clusters. The halo also includes dark matter, an invisible form of matter that exerts gravitational influence. 9. Spiral arms. The Milky Way has spiral arms, which are long, curving structures containing concentrations of stars, gas, and dust. Our solar system is located within one of these spiral arms. 10. Dark matter. Dark matter is a form of matter that doesn't emit light or electromagnetic radiation but exerts gravitational effects. It is thought to make up a significant portion of the Milky Way's mass. These components collectively create the complex and dynamic environment of the Milky Way galaxy. Studying the composition and interactions of these components helps astronomers gain insights into the galaxy's structure, formation, and evolution. Certainly, here are some additional and more recent developments and insights about the Milky Way. 1. Galactic cannibalism. The Milky Way has a history of interacting with and consuming smaller satellite galaxies. One such event is the ongoing merger with the Sagittarius dwarf elliptical galaxy, which is gradually being torn apart and absorbed by the Milky Way's gravitational forces. 2. The Gaia mission. The European Space Agency's Gaia mission has been creating a highly accurate 3D map of the Milky Way since its launch in 2013. This mission has provided data on the positions, distances, motions, and characteristics of over 1 billion stars in the galaxy. 3. The galactic bar. The Milky Way has a central bar-like structure that extends across its core. This bar is thought to be a region of enhanced star formation and activity. The bar is surrounded by spiral arms that spiral outwards. 4. Dark matter distribution. Studies of star motion within the Milky Way have provided insights into the distribution of dark matter, which is thought to be a major component of the galaxy's mass. The distribution of dark matter helps shape the overall structure of the Milky Way. 5. Stellar populations. Astronomers have categorized stars in the Milky Way into different populations based on their age, metallicity, elemental composition, and location. These populations provide clues about the galaxy's evolution and formation history. 6. Black hole at the center. Observations continue to support the presence of a supermassive black hole called Sagittarius A at the center of the Milky Way. Studying its effects on nearby stars and gas clouds provides insights into the nature of black holes and their influence on galaxy evolution. 7. Hubble's constant measurement. The precise measurement of the Hubble constant, a value that describes the rate of expansion of the universe, has implications for the Milky Way's age and its position in the cosmos. 8. Exoplanet discoveries. Recent advancements in technology and observational techniques have led to the discovery of numerous exoplanets, planets outside our solar system. Some of these exoplanets are located within the habitable zone of their stars, raising questions about the potential for extraterrestrial life. 9. Magnetism and cosmic rays. Researchers are studying the magnetic fields within the Milky Way and their influence on various processes, including the acceleration of cosmic rays, high-energy particles originating from various astrophysical sources. 10. Future surveys. Upcoming sky surveys and missions, such as the Rubin Observatory's Legacy Survey of Space and Time, LSST, and the James Webb Space Telescope, JWST, are expected to provide even more detailed information about the Milky Way and its components.